So today we're going to be talking over derivatives of trigonometric functions. So the first ones we're going to go over is the derivatives of sine and cosine. So whenever we have a function of sine, what happens is when we take the derivative of sine, it will change to cosine, and it will keep the sign of positive or negative. So if we had positive sine x like we have here, it becomes positive cosine x. However, if we had negative sine of x, the derivative will become negative cosine of x. Where if we had our function of x equaling to cosine of x, the derivative will be sine of x, just like we had for cosine of x, sine of x, just like we had here, where it changes to the opposite. However, when it's a positive cosine, it will become negative sine. So the sign of positive and negative changes. So if we had our function as negative cosine of x, our derivative will be equal to cosine of x. Now, when we have our function of x equaling to something where we have sine of 3x, the way that we take the derivative of this is by doing the chain rule. So when we do the chain rule, we take the derivative of the outside and then multiply it by the derivative of the inside. So what happens is we need to treat sine as our outside function and 3x as our inside function. So here, when we want to take our f prime at x, we will take the derivative of the outside, and if you remember, sine of x goes to cosine of x. So we'll write cosine, and then you keep the inside the same, and now we multiply it by the derivative of the inside, and the derivative of 3x just becomes 3. And it would be the same thing for cosine. So if our f of x is equal to cosine of 4x, the derivative, our f prime at x, will be equal to, now since this is positive cosine, we need to change the sign, so it will be negative sine, and now keep the inside bracket the same, which is 4x, multiplied by the derivative of our inside function. And our inside function is our 4x, which is going to be 4. So our final answer here would be negative 4 sine of 4x. So now, if we had our g of x equaling to 3 sine of x, we can treat this as a normal derivative. So if we have any constant k multiplied by our sine or cosine or any trig function, we're able to just take the constant out and then just do the derivative of our trig function. So here, since we can just take the constant out and then just do the derivative of sine x by itself, this will just become 3 cosine of x. Now if we continue this further, and we had our f at x equaling to sine of x, the way that this works is that the first derivative, our f prime at x, will be equal to cosine at x, but then our second derivative will be equal to negative sine at x, since it's just we're doing the derivative of cosine, and then our third derivative of x is going to be equal to negative cosine at x, and finally our fourth derivative of x is going to be equal back to sine of x. So it makes a full loop every fourth derivative. So let's say that we had our f at x equaling to sine at x. The way that we could solve it, if we were given a question where we wanted to find f to the 16th derivative of x, the way that we could do this is by splitting it into fourth derivatives. So we know that the fourth derivative is going to be sine x again. And now, if we did our same steps, we know that the fifth derivative, sixth, seventh, and eighth would always be the fourth derivative. So we know that the fourth derivative is just going to be a multiple of 4. So that will be 12 and 16, meaning that our 16th derivative of our function is going to be sine of x again. Now finally, if we have our function at x equaling to sine squared at x, what this means is to change this to more of a form that we're used to, we can make this equal to sine of x all squared. So now this is a form that we're much more used to because now this looks like a simple chain rule. So now when we want to find the derivative of our f at x, we do the derivative of our outside, which is by bringing down our exponent, keeping the inside the same, and dropping the exponent by 1, and now by multiplying it by the derivative of the inside function, which is our sine at x. And the derivative of sine of x is going to be equal to cosine of x. So this will make the derivative equal to 2 sine of x cosine of x. Now our final question is, if we put everything together, we get f at x is equal to 6 cosine squared at 3x. So the first thing we're going to do here is we're going to take the constant out. So when we're finding the derivative, we're going to have it where we ignore the 6 since it's a constant and we can just factor it out. And then we'll have cosine of 3x, and now this will be all squared. So now this again looks more like something we're used to. So we can make this 6, and now when we do our chain rule, since we have an exponent, an outside function of r to the power 2, and an inside function, which is our cosine of 3x. So the first thing we're going to do is drop down the 2 and make this cosine of 3x by keeping the inside bracket the same, and now changing it from 2 to 1 by subtracting 1 in the exponent. But now we need to multiply it by the derivative of our inside function. But the derivative of our inside function isn't just the derivative of cosine. It has to be another chain rule because we have our outside function of cosine and we have the inside function of 3x. So now we're going to do another chain rule. So to make this easier, I'll block it off, and then we'll have it where our cosine, the derivative, will turn to negative sine, and now that's the derivative of the outside function. And now we want to keep the inside function the same, and now we want to multiply it again by the derivative of our inside function, which is our 3x. So we'll just multiply it by 3, and then add our brackets back. So now, to make this look nicer, we have this as the derivative. We have our 2 cosine 3x as the first derivative of the outside, and now our negative sine 3x multiplied by 3 is the derivative of the inside function. So now we can do 6 multiplied by 2 multiplied by 3, which is 12 multiplied by 3, and now this is going to be cosine of 3x multiplied by negative sine of 3x. So now 12 multiplied by 3 is 36, and since we have a negative in front of the sign, we can just bring that out front. So we get negative 36 cosine of 3x sine of 3x.